Alright there kids, today we are going to work on the review for Chapter 5, your Chapter 5 pre-calculus test. So, first problem states that if tangent of theta equals 12 over 5, please define all 6 trig functions. Okay, since tangent is opposite over adjacent, I can put the theta in the corner over here of a right triangle and do opposite 12 over the adjacent 5. Now, how do I find that side 13? Well, that is a 3, 4, 5. No, but it's still a Pythagorean triple nonetheless. So you can use your Pythagorean theorem and find that side to be 13. So then you go through all your 6 trig functions. Sine is opposite over hypotenuse, 12 over 13. Conversely, the reciprocal of that is 13 over 12, and that is cosecant, because sine and cosecant are reciprocals. We go to cosine, which is adjacent over hypotenuse. Adjacent 5 over hypotenuse 13, and then reciprocal of that is secant, which is 13 over 5. And you know tangent already from the problem, so therefore you know what cotangent is. Remember your definition, SOHCAHTOA, or Oscar has a heap of apples. All right, verifying this trig identity for number 2 here. If you turn everything to sine or cosine, secant squared is just 1 over cosine squared. Cotangent squared is cosine squared over sine squared. And then you have that minus 1 from up top here, and that cotangent squared there. Well, when you do that, the cosines cancel out, because it's multiplication, and you're left with 1 over sine squared minus 1. Well, I change 1 over sine squared to cosecant squared, and cosecant squared minus 1 there, that's a Pythagorean identity. That equals cotangent squared. Remember, you do have to have the 3 Pythagorean identities memorized because they will not be on your formula sheet. Now, for number 5 here, number 5. We did numbers 3 and 4 in class in great detail, and you can look on D2L for the answer key for those. Now, this one here, I have all signs everywhere. Sine, everywhere the sign. So what I'm going to end up doing is simply subtracting 2 sine of theta from both sides of the problem. 4 sine minus 2 sine is 2 sine. Dividing both sides by 2. And then I look to my unit circle. Where is the sine of theta? Root 2 over 2. I can use my unit circle here because in the problem they said on the interval 0 to 2 pi. Root 2 over 2 is 45 degrees or 135 degrees. Now remember, also, you could do the radian equivalent. So 45 degrees is just pi over 4. 135 is 3 pi over 4. Either one is acceptable. It doesn't matter to me. This problem again, you have to subtract 4 from both sides and then divide by 3. We are isolated trig function, for there is just one of them. When there's one trig function, you isolate them. So divide both sides by 3, and then I get cotangent squared equals 1. I square root both sides. I get cotangent equals 1, and cotangent equals negative 1. And then when you look, where is the cotangent 1? That means x and y have to be the same. That's 45 and 225. Where are they? One positive, one negative. That's 135 and 315. Here, I set it equal to 0. And as you see in here, both of these have a cosine in them. I pull the cosine out as a GCF. And now I have something, this, times something else equal to 0. So I set both factors here equal to 0 and solve. Whereas cosine 0, 90 and 270. Or their radian equivalent. Whereas sine equal root 2 over 2, we've already done that one before previously. All right, so finishing up that problem, sorry for a little bit of a break. You set each of these equal to 0 and solve them. And look on your unit circle. Now this one, you try to set it equal to 0, but notice you have the cosine of theta and the sine squared of theta. I've got some problems here. Therefore, I need to use a Pythagorean identity, changing sine squared to 1 minus cosine squared, and distributing the negative 2. Now, why do I do that? Because now everything, as you see here and here, is in terms of cosine, and factor it out. If you're a little worried about that, just turn cosine squared into an x, and cosine into an x. And then factor that as such. And then once you do it like this, you put the cosine back in for x and set each factor equal to 0, like you did previously. Now when you do that, you end up getting cosine of theta equals negative 1/2, which happens at these two values, and the cosine of theta equals 1. Now, granted, you could use also 0 here. That would be perfectly mathematically acceptable, or 360, or the radian equivalent. Unfortunately here, I have a secant and a tangent, and there's no way to really relate them without squaring both sides. So I square them. Now, why would I square them? You have to FOIL. Don't forget to FOIL. That's important. Tangent squared. Why would I worry about that? Oh, it's secant squared theta minus 1. When I do that, set it equal to 0. The secant squareds cancel out, which is great. I get 2 secant theta plus 2. I subtract 2 from both sides, and then divide by 2. And where is the secant of theta equal negative 1? Well, that's just 1 over cosine equals negative 1. And where's cosine equal negative 1? At 180 degrees. Again, for this problem, square both sides. FOIL action goes on here. I square it because I have a cosine and a sine. There's no really to relate them. Then I set it equal to 0 and factor. And when I do that, I get 2 sine of theta equals 0 and 180 degrees, and the sine of theta equals 1. Now when I do this, you look on your unit circle for those values, or you give the radian equivalent. All right, now, for these problems, you need to create the triangles for both the sine of v, cosine of u, and the sine of m. Now the v triangle, sine is opposite, 12, over hypotenuse, 13. The other side is 5. It's a Pythagorean triple. Cosine of u, the u triangle, becomes adjacent over hypotenuse, 3 over 5. The other side is 4 by Pythagorean theorem, any Pythagorean triple. Now you use your formula, sine of u plus v. You look on your triangle here for these values. Now you multiply across the top here. 4 times 5 is 20. You could reduce this, but don't bother yet, because you're going to need a common denominator, which you will get with these pretty much all the time. And then add across the top and reduce if you can. Same here. Use a triangle from previous problem. So we go back to our triangles here. Okay. And find your values. Cosine of u. Cosine of v. Right here. The sine of u. The sine of v. That's a straight formula. You have your formula sheet out in front of you, provided you do not mark it up at all. So what you most certainly want to do is you want to take these two triangles right now for the rest of these, and you're definitely going to use those for the rest of the time. Now, notice cosine of 2v is a little different. I chose cosine squared of v minus sine squared of v. Again, there are two other formulas. You can pick either of them. It doesn't matter. You will get the same answer here. Cosine of v is 5/13. Sine of v is 12/13. And then you square both of them, squaring top and bottom. Look, common denominator, and subtract across the top. Sine of 2u. Unfortunately, you don't have many choice for this one. You go 2 sine u cosine u, which, again, formula. Sine of u is 4/5. Cosine of u is 3/5. Now you multiply here. Multiply the 4 times 3. Get 12. 5 times 5 is 25. And then multiply by 2. Do not multiply the 2 to both those numbers and get 8 and 6 and multiply them together. This one's a little rough. Again, formula here. Now, tangent. You go through the problem. There's my formula. You find the tangent of u is 4/3. Tangent of v is 12/5. 4/3 and 12/5. Multiply across the top here. And you get 48/15. Make this 15/15 because it's 1. Now, for these, you have to get a common denominator. It's 15. What times 3 gets me 15? Oh, 5. Top and bottom by 5. Multiply. This one is 3. Top and bottom by 3. Add across the top. You get 56/15. Now, remember, instead of dividing by something, we multiply by its reciprocal here, which is 15/-33. Cancel out the 15s. And cosine of 2u. Again, I picked the 2 cosine squared of u minus 1. Square these. Then multiply by the 2. And then subtract. If you picked any other formula, folks, you would still get the same answer. This completes the review. Good skill to all of you. You're all going to do spectacular. Hopefully everyone studies and studies well. Thus ends the review. Woo! and scene.